For years, we've seen these incredible, sometimes kind of terrifying technologies in movies and on TV, and we always thought, yeah, that's way off in the future. But what happens when that future shows up on our doorstep, like right now? That's what we're going to get into today, how that line between science fiction and our actual reality is getting blurrier by the minute. So here's the game plan. We're going to start with a classic sci-fi idea, and then look at how real-world tech is actually making it happen. From there, we'll jump into the AI revolution, see what it's doing to things like healthcare and our cars. And then we're going to wrap up with the really, really tough ethical questions that all this stuff forces us to ask. All right, so let's kick things off with an idea that I bet a lot of you will recognize. It just perfectly captures that feeling of a fictional world becoming a little too real. Yeah, Black Mirror. This idea is such a classic what if. I mean, what if you could perfectly remember everything, have a searchable database for your entire life? It sounds amazing, right? But it also brings up some seriously uncomfortable questions about privacy, jealousy, and what it even means to be human if you can never forget. And that's the thing. This isn't just a hypothetical anymore. The technology to actually record, decode, and maybe even transfer our thoughts, it's developing at an absolutely breakneck pace.
Which brings us to the real-world science behind the fiction, the brain-computer interface, or BCI. I mean, for so long, this was purely the stuff of comic books and cyberpunk. But now, it's a very real, very serious field of research with some mind-blowing implications.
So what's really fascinating here is that there are two totally different paths being taken. On one side, you've got your invasive BCIs. We're talking surgery, implants, the whole deal. It's powerful stuff, but as you can see, it's super limited right now. But on the other side, there's this whole new frontier opening up, non-invasive BCIs. The goal here is to get all that rich brain data without ever having to go under the knife. So you're probably asking, how in the world do you do that? Well, the key is this incredible breakthrough called digital holographic imaging. Instead of trying to read electrical signals through your skull, this system basically uses a super precise laser to detect the microscopic physical movements, like tiny little vibrations that happen in your brain tissue when a neuron fires. It's a completely new way of listening in on the conversation happening inside our heads. And just think about what this could mean. The potential here is just staggering. We're talking about technology that could help restore sight or mobility, give dementia patients their memories back, or offer brand new ways to treat severe depression. This isn't just about making us smarter, it's about healing. But, of course, having that kind of direct access to the human brain also opens a massive Pandora's box of ethical questions, which, don't worry, we are going to circle back to.
Okay, let's zoom out a little bit to the wider world of artificial intelligence. Because BCIs are one piece of this puzzle, but AI is really the engine that's driving a whole bunch of other sci-fi ideas into our daily lives.
At its heart, the way modern AI works is actually a pretty simple cycle. First, you feed it a truly massive amount of data. Then you give it algorithms to sift through all that data and find patterns. And then the magic happens. It makes guesses, sees if it was right or wrong, and learns from its mistakes, getting better and better over time. It's like having a student who never sleeps and is always improving. And if you want to see the real-world impact, just look at this. The projected growth in the AI healthcare market is insane. From $11 billion just a few years ago to a predicted $187 billion by 2030. This isn't some niche experiment. This is a tidal wave changing the face of medicine. I mean, come on, who doesn't remember the medical tricorder from Star Trek? That magical device you just wave over someone and get instant health readings. Well, guess what? It's happening. Thanks to AI's power to analyze tons of data from tiny little sensors, companies are building real-world tricorders that can measure a whole bunch of your vital signs at once, right in the palm of your hand. But, and this is a huge but, with all this power comes some serious risks. We're getting closer and closer to another Star Trek dream, the universal translator. But experts, like the computational linguist quoted here, are waving a giant red flag. And here's why. Current AI doesn't understand language. It just matches patterns. It has no idea about context or culture or what you really mean, and that can lead to some huge, potentially even dangerous mistakes. Okay, let's shift gears and talk about another sci-fi staple that's literally hitting the streets, self-driving cars. This is a perfect example of how these incredibly complex AI systems are starting to interact with our messy, unpredictable real world, and all the challenges that come with it. So the key thing to get here is that full self-driving isn't just an on-off switch. It's a journey through these different levels. We're pretty used to the lower levels, driver assistance, that kind of thing. We're even getting into level 3, where you can take your hands off the wheel sometimes. But that jump to level 4 and 5, where the car is truly 100% in charge and your mind is completely off the task of driving, that is a whole different ballgame.
And making that jump means we have to solve this entire laundry list of insane challenges, all at the same time. You need ridiculous amounts of computing power, but it has to be super energy efficient. You need almost zero delay and decision making. And you need to do all of that at a price point that regular people can actually afford. It's not one problem, it's a whole web of them.
And this is where the conversation shifts from engineering problems to something much, much harder. Because when we hand over control to a machine, we're not just handing over the steering wheel, we're handing over decision-making in a potential life or death moment.
Which leads us perfectly to what might be the trickiest question of all. And yeah, we're borrowing from Star Trek again. It's the perfect way to think about the ethical nightmare of telling an AI what to do when there are no good options left.
See, the whole point of the Kobayashi-Maru test is that it's impossible to win. It's designed to see what you do in a hopeless situation. For a self-driving car, this isn't a simulation. It's a horrifying potential reality, an unavoidable crash where the car's programming has to choose who gets hurt. And you have to ask, who gets to write that code? And this isn't just some philosophical debate for a college classroom. The title of this actual paper from MIT says it all. It's a stark reminder that this is a real, practical engineering problem. To program a car to be as safe as possible, you inherently have to program it for what to do in those awful, unavoidable moments. And this no-win problem isn't just about cars. Let's bring it all the way back to those brain-computer interfaces. They take these ethical dilemmas and stick them right inside our own heads. What about agency? If our thoughts can be read, can they be influenced? What about privacy? Who gets access to your literal memories? Who owns them? And what about equality? Will this tech create a new kind of gap between the rich and the poor? And maybe the biggest question of all, how does this tech change our very idea of who we are? At the end of the day, it all boils down to one simple word: trust. We are standing on the edge of a world where we give technology access to the most private parts of our being, our thoughts, our memories, our biology. Do we trust that that access will only ever be used for good? So we're moving into this new era where the things we build won't just change what we can do, they'll change who we are. The science fiction we all grew up with, well, it's the instruction manual we're now having to read. So the final question really isn't about what we can build anymore. It's about what kind of future and what kind of humanity we actually want to create.